Alright, so in this video we will be starting to know the solution based problems in the meshing. We have already done the mesh in our previous video. Now we will be moving on to the solving step. If you have saved your mesh file properly, you should see a tick mark in this mesh option. So now let's move on to the Fluent, as we will be solving our case in Fluent. Right click on this and drag it to mesh and double click on the setup. But before going to that, update the mesh so that it is being ready for the Fluent. So just go to the project display home, go to the mesh and you should see an update option, so update it. So you should see a message that says mesh transition to Fluent was successful. So now go to the workbench and now you should see a tick mark on here and the setup should be able to open. And remember to choose the double precision option. What it basically does is it enables a higher floating number of points to while you are solving a particular case. You see, basically the ANSYS Fluent will use a 32-bit single precision solver, but if you choose this double precision, it will use 64-bit floating points to solve your particular case, so error will be much less. And now I should start it. The Fluent is loading the file. So you can see okay, so our mesh file is loaded. If you have done proper name selection, you should see these arrows. If you hadn't done the proper name selection, you will not be seeing these arrows, and that is quite problematic. So remember, must do name selection in Design Modeler or in ANSYS meshing before coming into Fluent. So I have written down the steps for the solving option as well. So these are the steps for the setup for the solver. So I will encourage you to just read these steps and try the solving setup by yourself. So you can take a screenshot here, and I again encourage you to just read these steps and do it on your own. So anyhow, the step 1 is to choose the double precision in the ANSYS Fluent. We have already done that. The next step is to use the gravity acceleration in y direction in general setup. So go to general. The general is already selected. This is the task page for the general. Select the gravity and give it minus 9.8 meter. Sorry, 9.8 meter per second. So you basically understand what it does. It just adds a gravitational force on the fluid downwards and the y direction, so a negative. Alright, so go to the materials now. This is actually our next step. If you read the next step number 3, you should see what we will be doing next. So go to the fluid section first, double click on the fluid, and you see the so basically the air has been selected in the fluid materials. We have to change it to water. So go to Fluent database and you should see a list of materials. So I have to choose locate water. Water starts with W, so it should be at the last, should be lower water. You can see the water liquid here and option OK, and remember to copy it before closing it. Copy and then close. And similarly, go to the solid option, double click on it. Okay, so now go to the material type to solid and from fluid database, change it to solid, and use steel, coffee, and then close. Alright, this should be okay now, and now close it. Our next step is to go to the cell zone conditions. So the what cell zone condition it basically does, it basically ensures that what will happen inside the pipe. If you choose, there are many types of cell zone conditions. If you choose if you choose fluid, it will make sure that the fluid will flow inside the flow domain. If you have chosen solid, that it will make sure that no moving things happen in the domain, and it is only used while you are doing heat conduction analysis or FEM analysis. So this is not our FEM or heat conduction, it is a fluid flow, so thus we will choose a fluid in the fluid domain. So double click on it as well and change it to material name to water liquid, and make sure that the zone name is fluid domain. It is the name selection of the whole body, and apply and then close. Now our next step, if we look at our setup steps, now step number 5, we have the step number 4 as well in the boundary zone conditions, I mean the cell zone condition actually. The next step is to go for boundary conditions and change the velocity of velocity to 0.0 meter per second in the inlet zone. So I will be basically giving a boundary condition at the inlet zone. So double click on the boundary condition, double click on the inlet, you see a task page, and you should change the velocity magnitude to 0.01. Should be okay. Magnitude normal to boundary, reference frame absolute. Alright, so apply and close, and make sure that the other outlet velocity is 0. Momentum equation, normal to bound is the total pressure velocity. Alright, it should be okay as the pressure is 0 at the outlet, so it can be okay, but make sure that you select the wall and check for the no slip condition. Filter from here, and you should see a no slip condition at the shear conditions and wall motion to stationary wall. It is intuitive why you are choosing stationary wall and why you are choosing no slip conditions. So apply and close. So our next step is to go for the solution method to simplex scheme and use Green-Gauss cell based gradient. So go to the methods and change it to simplex. Actually what this scheme does, it's out of this bound of these videos, so I will simply explain it in one line. So simplex is a scheme that is abbreviation version of semi-implicit model for pressure linked equations consistent. So this is just a pressure velocity coupling algorithm that is used to satisfy the continuity. It calculates the pressure correction to satisfy the continuity, and you should basically use simple, but if you need faster convergence you must choose simplex, and change the gradient to Green-Gauss cell based, and it is basically the least square. It is least square cell based. You should use it when you are not confident in your meshing. Actually, if your meshes are very rough or you are not very confident with your mesh, use this least square cell based option, but otherwise you should use the Green-Gauss cell based option. So now it's alright. So the next step, we should move on to our next step. The next step is to go to solution initializations and use the standard initialization and compute from the inlet. So go to initialization, choose standard initialization and compute from inlet, and you should see basic velocity. Alright, so it should be okay. Initialize and go to run calculations. This is our next step actually, and give a number of iteration, a large number, and now you should calculate. It will take some time, but if we saw the convergence, we can stop the initialization. Well, after only 12 iterations, you can see the lines very straight. Let's let it run a bit. I will let it run at least 200 iterations. So if you feel bored, just skip for 5 seconds. Alright, 50 to 50 is also good. Now I will be stopping the iterations and okay. So this is the solving setup of the mesh we have done for our Y-shaped bent pipe. In the next video we will be learning about the post processing of the results.